In section 10.3, we're going to look at another type of plot that looks very similar to scatter plots, but these are called time plots. And time plots are very common. We see them in the news quite often. And here's an example of one. And this one is showing different social media platforms and how long it took each of them to reach certain revenue milestones. You'll notice on the horizontal scale, we have years, which is time, and it's not the actual year, but it's the number of years since each of those social media platforms was founded. And then on the vertical scale, we're looking at annual revenue. So at the high end here, we have Facebook, right? Facebook has reached the 70 billion point for annual revenue, but notice that it took them 15 or 16 years to reach that point. TikTok is the newer of these social media platforms that's shown on this graph here, and they have already reached the 12 billion annual revenue point, and it's only taken them about 6 years to reach that point. You can then pretty easily compare that to like Snapchat, which hasn't even reached the 10 billion point yet, or Facebook. Notice it took Facebook about 11 years to reach that 70 billion point. Twitter isn't there yet, and YouTube has exceeded 12 billion, but it took them 14 or 15 years to reach that point. So again, time plots are really useful for showing how things are changing over time. And in this case, we're looking at one variable, which is revenue, and how revenue is changing over time. So we should use a scatter plot to show the relationship between two numerical values. But if we want to show how one numerical value has changed over time, we use a time plot. Now, as an example, we're going to look at the football career of Emmitt Smith. And we know that football is pretty taxing on the body, especially for running backs who take lots of hits during games. It's pretty uncommon for running backs to have long careers in the NFL. Typically, usually 10 years is about the limit for running backs. But Emmitt Smith actually had a 15-year career in the NFL. So we're going to make a time plot showing Emmitt Smith's rushing performances over the course of his career. In your notes, you're provided with a table that shows the year that he played, his age at that point, and then his number of rushing yards. And notice that the graph that's provided for you in your notes is plotting age against rushing yards. So we're actually not using the year here. We're really more interested in his age at that point in his career than what year it was. So at age 21, he rushed for 937 yards. So we're going to go through and plot all those points just like we would on a scatter plot, where each pair of numbers, age and rushing yards, makes a point on the graph. So you'll notice that this does look very much like a scatter plot initially. However, with a time plot, we connect the individual data points with segments. So if we connect his performance at age 21 to age 22 with a segment, we can see that he had a pretty sharp increase between those two ages. And then from 22 to 23, he had another increase, although not as dramatic. And then the next year, he had a little bit of a decrease in his performance. And then we can just continue to connect all those individual dots with segments, showing how his performance has changed over time. Now, usually what we want to look at here are sort of overall trends. So you may have noticed that there was one point here where there was a really big dip in his performance that season. And that might be, I would guess, maybe he had an injury and that prevented him from playing a full season that year. But other than that, he had a pretty kind of steady decline going on, over the course of this time, some ups and downs in between, but overall the trend is a decline. So in your notes, when it asks you for any trends that you see, we would say that he had a very successful first few seasons, followed by a slow, steady decline. And again, we're sort of ignoring the individual ups and downs and looking at the overall pattern over time. Now, here are two time plots showing the average number of points scored per game by NBA teams from 1980 to 2009. Notice that the horizontal scale on both of these graphs is the same, but what we've done is we've changed the vertical scale. The one on the left is only going from about 90 to 115 points per game, while the one on the right is going from about 0 to 120. And notice that changing the vertical scale on these graphs makes the ups and downs seem much more dramatic. Back in first semester, we learned about misleading graphs and displays, and that was one of the tricks that are often used to sort of trick the reader of your graph into thinking that there are dramatic changes when there really aren't. And so the second plot shows that more accurately. Now, the last thing we're going to do is kind of talk about how we can better look at overall trends in a time plot. Because remember, we said really we don't care about the individual ups and downs so much as we do the overall trend. And so we can kind of smooth out the overall ups and downs by plotting what's called a moving average over time instead of plotting individual performances for each year. This works really well because averages of several performances tend to be less variable than the individual performances themselves. So we're going to do that with Emmitt Smith. We're going to calculate some 3-year moving averages to examine how his career changed as a running back. Now, notice in the chart, the first box there is grayed out for you because it's not possible to calculate a 3-year moving average for the first year of his career. However, we can for the second year, and that one is already filled in for you. So this 1,404 is the average of that year, the year that came before it, and the year that came after it. So if we added those three rushing yards up and divided by 3, we would in fact get 1,404. So we're going to do that now to fill in the rest of the chart. In the first one, for example, we have this blank at age 23. And to get that missing moving average, we would need to average together the season before it, that given season, and the season that came after it. So if we add those three values together and divide by 3, we would get a moving average of 1,587. Now, the next couple are given for you. The next one that's missing is age 26. And to get that missing moving average, we would average together that season, the one that came before it, and the one that came after it. So we add those three together, divide by 3, and that would give us a moving average of 1,487. Now we're going to kind of repeat that and fill in the rest of the chart. So I would recommend at this point that you pause the video and try the calculations yourself and then restart it and see how you did. Right, at age 29, his moving average would be 1,268. At age 30, it would be 1,311. And at age 33, 751. Now, in your notes, you have the original time plot on the left, and we have the new plot of the moving averages on the right. And notice that they show the same overall pattern. They just don't show the dramatic ups and downs that we see when we look at the original time plot, especially toward the end of his career where he had this one season that was sort of abnormal compared to the rest. So what we're seeing here is the same overall trend with less extreme ups and downs. Please do homework 10.3 in your assignment packet.